Hello friends, in the last 4 videos we have solved first 12 example from exercise 5.3. Now we are starting example number 13. So now try to understand here. The example is very easy, but try to understand the concept in a proper way. So now here what is the given condition? The direction ratios of AB bar are given to us. Means one vector is there AB bar and its direction ratio. Generally we are denoting direction ratios by what? A, B, C. And coordinate of A is also given to us. Coordinate of point A is given to us and this length of AB is also given to us. Using all these conditions we have to find out coordinate of point B. Now here what is given to us, let us suppose that this will be say one line and let one point is there on this line, point A, and its direction ratio, we can say that these are the direction ratio of AB bar or these are the direction ratio of line AB, isn't it? And now coordinate of this point A is also given to us. What are the coordinate of point A? 4, 1, 5. Direction ratios are also given to us. Now this AB is equal to 6. AB is equal to 6 means we have to find out for such point B which is at how much distance? 6 units. 6 unit from which point? A. Now there are two possibilities. Maybe possible that point B is on the right hand side of A, or maybe possible that point B is on what? Left hand side of. Means there are two possibilities that we are getting 2 points on the same line which are at a distance what? 6 unit from point A. Means maybe possible that point B is on this side, or maybe possible that point B is on this side, but at what? On the same line and at how much distance? 6 unit. Okay. Now from these direction ratios we are able to find out coordinate of direction cosines. If we are denoting coordinate, if we are denoting direction cosine say by what? LMN. If LMN are what? Direction cosines. Already in some example we have seen how to find out direction cosines if direction ratios are given. So using direction ratio we are able to find out direction cosines. Now our aim is to find out coordinate of what? Point B. Let us denote this coordinate by what? X1, Y1 and Z1. Means coordinate of point A we are denoting it by X1, Y1, Z1. Then coordinate of point B are, B is at how much distance? 6 unit. From which point? A. So here we can say that X1, its Y coordinate will be Y1 and Z coordinate will be Z1. Now we are trying to find out one formula to find out coordinate of which point? B. Now already we have written here coordinate of point A. Okay, now from this coordinate we are trying to find out coordinate of point B. Now once the direction cosines are known to us, means on this line we have to find out what? Coordinate of point B, which is at how much distance? 6 unit. In one important result we have seen that if LMN are nothing but direction cosines of a line, then unit vector along that line is what? Li cap plus mj cap plus nk cap. And we have seen how we have got this result also. I think when we have proved the relation between direction ratios and direction cosines, at that time we have seen how we have got this result. So if LMN are what? Direction cosines of a line, then Li cap plus mj cap plus nk cap is nothing but what? Unit vector. Now we are trying to find out a unit vector whose initial point is what? A. Whose initial point is A, and if it is a unit vector means its magnitude is 1. And if we are multiplying to it by what? 6, then we will get a new vector whose magnitude is what? 6 unit and initial point is what? A. So and what we are finding here? B. B is at how much distance? 6 unit. So that's why here we are adding what? We are adding 6L, and here we are adding 6M, and here we are adding 6N, because L, M, N are nothing but what? Direction cosines. Direction cosines, and if we are multiplying to it by what? 6. So we will get coordinate of such point which are at how much distance? 6 unit from which point? A, and along the same line, because we have considered direction cosines of this line. But already we have discussed that how many possibilities are there. There may be possible that 2 points are there. If one point is on left hand side, to find out coordinate on right hand side, to find out coordinate of a point on left hand side, so we have to take what? Minus here. If we are taking plus or minus, Plus means we will get coordinate of a point on one side, and if we are taking minus, we will get coordinate of again one point which is on the another side, means left hand side. Getting it? So that's why here we have taken plus or what minus, because there are two possibilities that we are getting 2 points on the same line which are at distance how much? 6 units. 6 units from which point? A. So try to understand this method. So here see what is the given condition. Coordinate of point A is given to us. Length of AB is equal to, sorry, here 6 unit is there, and direction ratios of AB bar is also given to us. Let us denote these direction ratios say by A, B, C. I am denoting these direction ratios by ABC. Say means suppose, let us suppose that denoted by what? ABC. So now once these direction ratios are known to us, then direction cosines are what? A upon under root, B upon under root, C upon under root. So that's why we are finding value of under root. Under root what? A square plus B square plus C square. So which is equal to under root, what we will get here? Minus 2 square plus 2 square plus 1 square is equal to root 9. 4 plus 4, 8 plus 1, 9 is equals to 3. So therefore we can say that direction cosines of AB bar are, so A upon under root means minus 2 upon 3, minus 2 upon 3. Then B upon under root, value of this under root is how much? 3. So here we will get 2 upon 3, and lastly we will get 1 upon 3. Once these direction cosines are known to us, denote these direction cosines by by L, M, N. So here we are saying that let L will be equals to minus 2 by 3, M will be equals to 2 by 3, and N is equals to 1 by 3. Again, I am denoting the coordinate of point by x1, y1, z1. Let coordinate of point A be x1, y1, z1. So this implies that x1 will be equals to, what is the value of x1 then? 4. What is the value of y1? y1 means y coordinate. Here y coordinate is already given to us 1, and z1 will be equals to how much? 5. And this distance I am denoting it by d, and d is equal to 6 units. So this distance is equal to 6 units. So therefore coordinate of point B are, then what will the coordinate of point be? X1 plus 6L plus or minus 6L, then 6L, or we can say that DL, then Y1 plus or minus DM, and here Z1 plus or minus DN. So using this formula we are finding coordinate of point B on the same line. On which line? AB. And at how much distance? 6 unit. From which point? A. So already here coordinate of point A are x1, y1, z1, and we are adding what? D. D means what? 6 unit. So we are finding such point on this line which are at a distance 6 unit from which point? A. So well, let us simplify it. Let us substitute the values. So therefore coordinate of point B are, so what is the value of x1 here? X1 will be equals to 4. 4 plus or minus 6. D is equal to 6 into L. L is equal to minus 2 by 3. So this will be your x coordinate. Now to find out y coordinate, y1 plus y1 is equal to 1 plus or minus D is equal to 6, and here M is equal to, what is the value of M? 2 by 3. Lastly, Z1 is equal to 5 plus or minus D means 6 into what? N is equal to 1 by 3. So let us simplify it. 4, keep it as it is. Now here we can observe that if you are multiplying by minus to both the signs, minus into plus will become minus, and minus into minus will become plus. Parallelly we are simplifying it. 2 6 12 upon 3 is equals to 4. Here 1 plus or minus, keep it as it is. Here also 2 6 12, 12 upon 3 will be equals to 4. And here 5, keep it as it is. Here 6 upon 3 will be equals to 2. So this implies that coordinate of point B are. Now here we are considering minus plus plus. then see what result we will get. Here 4 minus 4 will be equals to 0. Here 1 plus 4 will be equals to 5, and 5 plus 2 will be equals to 7. And another coordinate of another point on the same line which is at a distance 6 unit will be equals to, here consider plus minus minus. So 4 plus 4 will be equals to 8. 1 minus 4 will be equals to minus 3, and 5 minus 2 will be equals to 3. So again check here, 4 plus 4 is 8, 1 minus 4 will be minus 3, and 5 minus 2 will be equal to 3. In this way we have got 2 points which satisfies all the condition in the example. So hope you have got it. How many points exist which satisfies given condition? 2 points, which are at how much distance? 6 unit. If you want to check whether answer is correct or not, you are able to apply distance formula also. Try to find out distance between these 2 points and check whether you are getting same value 6 unit or not. And even once the coordinate of 2 points are known to us, you are able to check whether these are the direction ratios of line AB or not. Direction ratios can be find out as what? X2 minus X1, Y2 minus Y1, and Z2 minus Z1. Applying that formula, you are able to find out direction ratios also. Now observe the last example from this exercise, example number 14. So if you'll observe in this example, question is to find out acute angle between the lines whose direction cosines LMN satisfies these two equations. Means here two lines are given to us and direction cosines of these two lines satisfies these two relation. Using this we have to find out angle between two lines. Now here many examples can be constructed and can be solved using exactly using same method. So in this case these two equations are satisfied by what? Direction cosines of a line. Sometimes relation between direction ratios of two lines are given to us, and at that time also question can be asked to find out only the direction ratios or find out direction cosines, or question may be asked to show that lines are perpendicular, or question may be asked to show that lines are parallel, or question may be asked to find out what? Acute angle. In every example 90% part is common, means solving given two equations. First our aim is to find out what? Direction ratios. Once the direction ratios are known to us, then if question is to find out direction cosines, find out direction cosines. If question is to show that lines are perpendicular, then using direction ratio we are able to show that lines are perpendicular, or question may be asked to find out what? Acute angle between two lines. Means 90% in all such example is similar. The method which you are applying in this example, same method is applicable in every example. If relation between direction cosines of two lines are given to us, or relation between direction ratios of two lines are given to us. Here these are two relations which are satisfying by direction cosines of two lines. In all such example, solve these two equations in such a way that you are able to find out what? Direction ratios of the line. So already here we have considered two equations, both the equation, first equation we have denoted by 1, and let us denote second equation by 2. Now from equation number first we will have three choices. Either find out value of L and substitute in the second equation, or find out value of M and substitute in this equation, or find out value of N and substitute in the next equation. So we are giving priority here to find whatever may be the first letter here. Not necessarily always the direction cosines are denoted by LMN. Sometimes the relations may be given in terms of ABC, or maybe in terms of what? PQR also. So now here as is stand these relations are in terms of LMN. So in such cases whatever may be the first letter here, I am giving priority. That is your choice. You are able to substitute value of L also, or M also, or what? N also. As is stand here from equation first I am finding value of L. So from equation first L will be equals to, let us see what value of L we will get. Plus M on this side will become minus M. Plus 3n on this side will become minus 3n. And 5 is multiplied to L on this side, it will get divided. So in this way we have got the value of L from equation number first. Again try to understand, you have a choice. You are able to substitute value of M also or value of N also. Now put this value of L in equation number second. Let us denote this value of L say by equation number 3. So put L is equals to minus 5 minus 3n upon 5 in equation 2. So let us see what we'll get. Keep first term as it is, 5mn as it is, minus 2n also as it is, minus 2n also as it is. I'm just replacing L by its value. What is the value of L? Minus m minus 3n upon 5. Okay. Now here plus 6m, keep it as it is, plus 6m as it is, and replace this L by its value, minus m minus 3n upon 5. Okay. And on this side keep this 0 as it is. Just two terms of L appears in this equation, and both the L we have replaced by this value. Now this is the equation in terms of what now? M and L. L is eliminated because we have substituted the value of L here. Now solve this equation. See what result we will get here. So 5mn, keep it as it is. I am multiplying by 2n to both the terms in this bracket, and here I am multiplying by 6m to both the terms in this bracket. Parallelly to since already the example is very lengthy, so better way to avoid the step, I am multiplying by 5 to eliminate this 5 from the denominator. I am multiplying by 5 to both the sides. See what we will get if I am multiplying by 5 to first term. So here we will get 25mn. Getting it? I am multiplying by 5. If I am multiplying by 5 to second term, this 5 and 5 will get what? Cancel. And here also 5 and if I am multiplying by 5 will get what? Cancel. Means fraction will get eliminated. Hope you have got it. Now I am multiplying by minus 2n. 5 is already eliminated because we are multiplying both sides by what? 5. Now I am multiplying by minus 2n to both the terms in this bracket. Minus into minus will become plus, and 2n into m will be equal to 2mn. Again here minus into minus will become plus, 2 into 3 will become 6, and n into n will become what? N square. Now here also 5 will get eliminated since we are multiplying both sides by 5. Now multiply by 6m to both the terms in this bracket. Plus into minus will become minus, 6m into m will be 6m square. Here plus into minus will become minus, and 3 6 are 18, and m into n will be mn is equal to 0. Now first write down the term of what? M. So m square. So here one term of m square is there, minus 6m square. Collect the terms of mn. So here 25 plus 2, 27. 27 minus 18 will be 9, plus 9mn plus 6n square is equal to 0. So to eliminate this minus, or our priority is that first term should be positive. So that's why I'm multiplying both sides by minus. If I'm multiplying both sides by minus, let us see what we'll get here. So here we will get 6m square. Even we can observe that all the terms in this equation are divisible by 3 also. So to cancel this minus, I am dividing both sides by minus 3. If I am dividing to first term by minus 3, here we will get 2m square. Divide by minus 3, here we will get minus 3mn. Divide by minus 3, here we will get minus 2n square is equal to 0. Just simply we are dividing both sides by what? Minus 3. If I am dividing by minus 3, we will get this expression. So already you have solved quadratic equation. Same method we are applying here. So 2 into minus 2 will be equals to what? 2 into minus 2 will be minus 4. Now find out factors of minus 4 such that their addition is minus 3. So its factors are minus 4 into 1, their product is minus 4, and their addition is what? Minus 3. So keep this first term as it is, 2m square as it is. This middle term can be split up as minus 4mn plus mn minus 2n square is equal to 0. Keep it as it is. Okay. Now from first two terms we are able to take 2m common. If I am taking 2m common from first term, here remaining term is m. If we are taking 2m common, here remaining term is minus 2n. plus, now from last two terms we are able to take n common. If we are taking n common, so here remaining term is m and here remaining term is minus 2n. On this side 0 keep it as it is. Now if you observe both the terms here, we are able to take m minus 2n, m minus 2n common from both the term. If we are taking m minus 2n common from first term, so here remaining term is 2m and here remaining term is n is equal to 0. Now product of these two term is 0, means either first term is 0 or second term is 0. So therefore m minus 2n is equal to 0 or 2m plus n will be equals to 0. So this implies that m will be equals to minus 2n, on this side will become plus 2n, or here m will be equals to plus n, on this side will become minus n divided by 2. In this way we have got two values of m in terms of what? N. See here, direction cosines we have denoted by what? L, M, N. In such example, now as is stand in this example, I am trying to find out value of L also in terms of n, M also in terms of n. Already the value of m in terms of n is known to us. Here also value of m in terms of n is known to us. We are getting two values of m here. Since how many lines are there? Two lines are there. So we are getting direction cosines of two lines. Okay. So now when m is equals to 2n, at that time let us see what value of L we are getting. Observe the equation number 3. In this equation number 3, I am replacing this m by its value. What is the first value of m? 2n. See what we will get here. Minus, keep it as it is. Substitute this m is equals to what? 2n. 2n minus 3n, keep it as it is, divided by 5 also as it is. Let us simplify it. What we are getting in the numerator, minus 2n minus 3n is minus 5n. Minus 5n upon 5 will be equals to what? Minus n. Means value of L in terms of n is also known to us. Now we are using second value of m. When m is equals to minus n by 2, at that time let us see what value of L you are getting here. Okay, so again observe this equation, minus, keep it as it is. This 1 by 5 we are taking it on one side, 1 by 5. Okay, and we are replacing m by what? Minus n by 2. So this m we are replacing by minus n by 2. Minus and this minus will become plus, plus n by 2. And here minus 3n, keep it as it is, minus 3n, keep it as it is, which is equals to, let us simplify it, see what we'll get if we are taking cross multiplication. 2 into minus 3 is minus 6. N minus 6n will be minus 5n. Minus 5n upon 2. So 5 will get cancelled, and what will get? Minus n by 2. Again observe here this difference will be what? Minus 5n upon 2. And 5 and this 5 will get cancelled. So lastly we will get minus n by 2. So this value of L in terms of n is known to us. Here also value of L in terms of n is known to us, and value of m in terms of n is also known to us. Now we are finding direction ratios of line first. So therefore direction ratios of line first are. So we are trying to find out direction ratios of line first. Already we know that direction cosines are also called as what? Direction ratios, but its converse is not true. So what are the direction cosines? What is the for first line? L is equal to what? Minus n. So here L is equal to minus n. Just we are writing the value of L, M and what? N. So first we have written the value of L. Already what value of L is we have got here? Minus n. And when value of L is minus n, if m is equal to what? 2m, means m is equal to 2n. And n is equal to n, means value of L we have got in terms of n, m is also in terms of n, and n is already n here. Just we have got it. What we are trying to find out? L in terms of n, m is also in terms of n, and we are not disturbing to n. So that we are able to cancel what? Common factor. So that is, if we are dividing, these are the direction ratio, we are able to cancel the common factor. So what result we will get here? Minus 1, 2, 1. Let us denote these direction ratios by A1, B1, C1. Okay, and direction ratios of line second are. Let us try to find out direction ratios of second line. Now for second line, what is the value of L here? L is equal to minus n by 2. Minus n by 2. What is the value of m? M is equal to, m is also minus n by 2. Minus n by 2 and n is equal to n. Let us simplify. These are the direction ratios, means we are able to convert it into simplest form. First I am dividing to all the terms by what? N. So let us divide to all the terms by n. So here we will get minus 1 by 2. Here we will get minus 1 by 2 and here we will get 1. Just we have cancelled the common factor n here. Now for simplicity, these are what? Direction ratios. Direction ratios means we are able to cancel common factor, means we are able to divide to all the term by its common factor, or we are able to multiply to this ratio. Since these are the ratio, we are able to multiply to all the terms, or we are able to divide to all the terms. To eliminate the fractions, means for simplicity, your fractions are there. To eliminate the fractions, better way what is in the denominator? 2 is in the denominator. So multiply by what? 2. And here we can observe that two terms are negative. If you want to eliminate negative signs also, so we are multiplying by minus 2 here. Let us see what we will get. That is, if we are multiplying by minus 2, here minus into minus will become 2, 2 will get cancelled, means remaining term is 1. Here also if we are multiplying by minus 2, remaining term will be 1. If we are multiplying by minus 2, here we will get minus 2. Just we are simplifying it. These are the direction ratios. Cancel the common factor. And why we are multiplying here by minus 2? To eliminate what? Fractions. Okay. So denote these direction ratios by A2, B2, C2. See, once the direction ratios are known to us, maximum result related with direction ratios we are studying in what? Lines. In the next chapter, lines and what? Planes. I don't know why they have given this example in vectors, but well, as is planned, this example is given in what? Vectors. So this example is related with what? Lines. If direction ratios of two lines are known to us, at that time many results are there related with direction ratios. Using direction ratios, we are able to find out direction cosines also. We are able to show that lines are perpendicular also, parallel also, or we are able to find out angle between two lines also. So as it stand, here we have to find out what? Angle between two lines. Now as we are studying here vectors, we have not studied a formula related with what? Direction ratio, which we are studying in next chapter. Now using vector method, we are trying to find out angle between what? Two lines. Okay. So in every example, remember that this much part is common, which means this part whole. Whatever maybe the two equations are given to us, solve these two equations. And solving these two equations, try to find out direction ratio of line first and direction ratio of line second. Means 90% method in every example is same. Only what will get changed? These two equations will get changed. But the method to solve the equation in every example will be same here. Now using these direction ratios, using vector method, we will try to find out what? Angle between them. Now using these direction ratios, we are trying to find out angle between these two lines. So let us denote the vector along first line by A bar. So let A bar and B bar be the vectors along line first and second respectively. Means here let this will be say first line and this will be say second line. So we are denoting the vector along first line by A bar and vector along second line by what? B bar. So A bar and B bar are the vector along this line, and if I am saying that theta is angle between these two lines, means theta is angle between what? A bar and B bar also. So already when we have proved the relation between direction ratios and direction cosines, at that time we have seen that if vector along the line is given to us, we are able to find out its direction ratio. Or if direction ratios of a line are known to us, we are able to find out value of vector along that line. So adjacent direction ratios are known to us. So from this direction ratio, so the vector along first line is, so minus I cap, what are the direction ratios here? Minus 1, 2, 1. So therefore vector along that line is minus 1 plus minus I cap plus 2j cap plus k cap. This value we have got from this direction ratio. Using same method, we are trying to find out vector along the line second from the direction ratio of second line. And b bar is equals to the vector along second line we have denoted by b bar. So what will be its value? I cap plus j cap minus 2k cap. Now denote this angle if theta is acute angle between the lines, then cos theta is equals to, what is the formula to find out value of cos theta? A bar dot b bar upon magnitude of a bar into magnitude of b bar. If theta is the angle between a bar and b bar, then applying this formula we are able to find out cosine angle between them. And if we are giving here mod, means we are finding positive value of cos theta. If value of cos theta is positive, means we are discussing about what? Acute angle. We know that if two lines intersect each other, if one angle between them is acute, then another angle will be what? Obtuse here. Our interest is to find out acute angle. So substitute the value of a bar and b bar here. So value of a bar dot b bar. So already value of a bar and b bar is known to us. Substitute these values. Minus I cap plus 2j cap plus k cap. Dot, keep it as it is, then substitute the value of b bar is equal to I cap plus j cap minus 2k cap. In the denominator we are finding magnitude of first vector, that is under root minus 1 square plus 2 square plus 1 square into under root. Now find out the magnitude of this vector, 1 square plus 1 square plus minus 2 square. So which is equal to, here what will get? Minus 1 into 1 will be equals to minus 1. We know that if vectors are represented in Cartesian form, at that time to find out dot product, first take the product of coefficient of I bar, then take the product of coefficient of j bar, and lastly take the product of coefficient of k bar, divided by, see what we will get here, 1 plus 4 plus 1 will be equals to root 6, and here square of 1 is 1, square of 1 is 1, and square of minus 2 is 4. 4 plus 1 will be 6. So in the numerator, plus 2 and minus 2 will get cancelled, we get minus 1, and in the denominator root 6 into root 6 will be equal to 6. This is the value of cos theta. So cos theta is equal to mod of minus 1 by 6 will be equals to plus 1 by 6, which implies that theta is equal to, take cos on this side, so it will become cos inverse of 1 by 6. So what is theta here? Theta is nothing but angle between two lines. In this way we have got the value of theta, which is nothing but angle between what? Two lines. So hope how to solve this example is clear to you. Such type of examples are given in miscellaneous exercise also. Same method we have to apply in every example. So two equations are given to us. So solve these two equations. Solving these two equations, first find out direction ratio of line first, then find out direction ratio of line second. And once the direction ratios are known to us, then whatever may be our question, try to solve that question using direction ratio. As it stand, our example is related with what? Finding angle between two lines. So using this method, so first find out vector along the line first, vector along the second line. Already we will have one formula to find out angle between two lines directly using what? Direction ratio. But that formula we are going to prove in the next chapter. And even in this case, the answers given on the last page are also wrong. Some corrections are there. So here whatever may be the value of direction ratios we have got, here these values are absolutely correct. Some corrections are there. Already this textbook is what? New. So might be possible some print mistakes are there. But remember that already this example is in the syllabus, is in old syllabus also. So I'm very, I have gone through this example many times. So these values are correct here. These are the direction ratios of two lines. Some print mistakes are there in the answer given on the last page. Okay. So in the next video we will start next exercise. Well, now we will stop.